So we take projective plane. It is given by this, right? So if you take rectangle, right, and if you identify uh, these edges like this, if you identify this, so this is basically V, W, okay, this will be V, W, A, A, B. Then you have this is C, and then you have U and then L. Okay. Now this is what uh, so how many zero simplices are there? V and W, two, right? So it is Z plus Z, and it is spanned by V and W. Now delta 1 X. So how many one simplices are there? B, A, and C. So 3. B and C. How many two simplices are there? Oh, U, this one, and this one. So Z plus Z, span of U. So here uh, 1, 5, A, this is what, so A has like this, so this is going to be B, and B, if you apply B, then what will you get? And this is, see, this is WV, so it is V minus W, and C, so it's both the, so both the vertices of this edge are same, so it is V minus V, it is 0, right? So hence X equal to image of 1. So image of this boundary map, uh, it is generated by V minus W. You see, A goes to this, B goes to C. This is nothing but minus of this, and this goes to C. So span of V minus W equal to Z. Okay. Uh, so this is what uh, quotiented by. So this is always this. This is always zero, right? Because this delta on x zero. This is delta one x one, right? You have, so this is always zero because this is zero. So this is your kernel is whole delta naught x, right? So delta naught x is this, right? Uh, and it is spanned by v and w, right? So because it is spanned by v and w, we can say that it is spanned by. So this is actually span of v minus w. Okay. So we can write like this also. So and v naught x is span of v minus w, right? So this uh, one will be cancelled. So this is this, right? The question, because v naught x is spanned by v minus w, and this is spanned by v and v minus w. So this will be spanned by v, right? So now what is this kernel of this? So let us elements of this delta 1x, they will be linear combinations, right? So PA plus QB plus RC equal to what? Delta 1A B, this is Q, and this is your A plus R. This is W minus V plus Q V minus W plus this is 0. This is what? Basically Q minus P to W. So implies this is 0. This is 0 means P equal to Q. Okay. So Z1 X, this is kernel of boundary 1. This is, so if your P equal to Q, then what this element will be of this form: P A plus B plus R C, right? So kernel will be generated by P. There is no restriction over P and R. So kernel will be generated by A plus B and C, right? So span of plus B and C. z plus z. Now so let us see how x u. Okay, so we are considering this VWV, right? Sorry, U is this one, so we can consider VW the V, something like this. So this orientation. Then this is going to be. So if you remove this one, then you have WV, right? W WV with the positive sign. So it is B. Then minus, if you remove this, then this one, this one is minus C, but it is with minus sign, so it is plus C. And then last one, if you remove this one, then we have this plus sign. So so depending on what orientation we choose, these things may differ, right? So what orientation we choose for this one, what orientation we choose for this one. So I have chosen here this orientation, okay, the VW, and here I will choose this orientation, so VWB, right? So L, what it is. So if you remove this one, then we have WV with positive sign, so it is B plus. If you remove this one, then we have this negative sign, that is this is going to be minus C. Uh, and then when you remove this one, we have this positive sign, so B minus C plus E. Okay, now so we have to see yes. So this kernel here, so this B1C, So this boundary map delta 2 uh, this comes out to be injective. First of all, let us settle that. So z2x equal to kernel of the map. So this is going to be this is injective because if you put pu plus ql boundary 2 equal to 0, then we are going to have this b plus c plus a plus q p minus c plus a equal to 0. Now this will give p plus q b plus here c p minus q equal to into c plus a p plus q 0. This implies p plus q to 0, p minus q equal to 0. But this implies what? Uh, if you just add these two, then 2p is 0 implies p is 0. But then q also is 0. So this this equal to 0 implies p and q both are 0. So its kernel of this boundary map is trivial. Okay. Hence second homology group is going to be trivial. Now with this we want to see what is this b1x, right? So this image of this map, right? So this takes this one to this and this one to this. So from this, if you just if you be subtract this from this, so we'll get b plus c plus a minus of this will give us 2c, right? So okay. So a plus b plus c. So we can span a plus b plus c, right? So we can span this image with the help of a plus b plus c and 2c, because you see a plus b plus c is this one. If I subtract 2c from this, then a plus b minus c, so we'll get this also. and from this we can get these two. So this is going to span this, right? And Z1x is span of, you see, A plus B and C, they span this, but then A plus B plus C and C, right? They will span and C. These these will they will span this Z1x, right? Because from these two we can get these two, and from these two we can get these two. Hence, H1x basically RP2 is going to be, you see, here 2C is there, here C is there, right? So when you quotient this by this one, so you have spine of C quotiented by spine of 2C. So this is going to be basically uh, Z2, right? So this gives first homology group of projective plane. Next, we want to compute